All right.
It's helpful sometimes to be able to
If you're
refer
opposed to
back.
being recorded, please disconnect now. All right, cool. Don, I mean, I'm not, we're not gonna do anything formal, so I'm just gonna turn it over to you. You should be able to share your screen. If you get a permissions issue, let me know.
Okay. So you should be seeing
Right
the
now, I
deck.
see Don.
I
Well,
tweaked it a little.
I don't see you sharing anything yet. Oh. See your
Camera
hand.
came back.
So do you click the green share screen
Yeah.
button down at the bottom? There we go.
There we go.
Cool.
Okay, so this is a deck. I've tweaked it a little bit since you saw it last, Jeff. The big thing is we're gonna have a set of questions we're gonna ask you at the end. So I thought I'd ask them at the beginning. We're trying to understand who's actually interested in working on this alternative project. And we're also going to be curious about which of the various approaches you're interested in doing. We need to have a discussion on how we get quantitative testing. We can check that something works. Is it working well? And then John has suggested we have APRS expeditions in the spring, so I'm going to suggest we talk about that. This all got started with a knowledge sharing session that Jeff triggered. And there was one in August, one in September, and the basic core of that was people were interested in considering an alternative. Most of the discussion was around Raspberry Pi, some form of sound card, and probably the Direwolf software. So that brings us to the first question, just for confirmation. What are people interested actually in working on a potential alternative to the D710? And I'll be more precise. An alternative to the D710, which we could be used for testing in parallel during the 2022 AT Golden Packet effort.
I'll say yes.
Yes.
And I'm a yes. So we got, and I believe John's a yes.
Yeah, I put my thumb up with the reactions.
Yeah,
Yeah,
I can't see
so-
the screen. I'm looking at the presentation. I can't see the people yet. All right, so it's the 4 people. Anyone else interested in playing?
Yes. WB2.
That is,
Yeah, this is Ron. I have almost zero experience with the Raspberry Pi, but I'm willing to learn.
sounds like a plan.
Yeah, and that'll actually be good because it'll make sure anybody can do it, not just people that know the Pi.
Awesome.
True enough. All right.
And then John.
So there is interest in
John, I got
essentially
you as well.
everybody on the
WB
meeting
hang
tonight
on,
is
slow
interested
down.
in playing.
Slow down. We had John, WV2 OSE was talking to, and somebody cut him off there, so.
I just
Go
said
ahead.
yes. Yes, I'd like
Okay,
to
all right.
participate in some way.
I'm a stowaway on your
So
Zoom meeting here today, but
this
I'd be
is
very
a
interested in
block
hearing this.
diagram of the basic APRS deployed systems. I've been tweaking this as we went along. There's always an RF physical layer if we're doing APRS over radio, and that's a transceiver. That's sort of, we haven't been talking much about that, although John's been doing some work with new transceivers. There's what I call the packet management layer, which is these days a hardware and software composition. There's the APRS application code that does things like digipeating and beaconing. This is the layer that doesn't need human interaction. And then there's an interactive interface, and it was Lynn who actually tweaked me to redo the boxes to have that as a separate layer. And if you look carefully, the way we're presently constructed, the interactive layer and the APRS application layers typically need location services. So if you put together any system, it will have some combination of these boxes. They may be combined into a single component, but these boxes in some form will have to be there. And what we're really talking about is how will we satisfy the functions of these boxes? Any questions on the block diagram? moving forward. These are the alternatives that have been looked at so far or been raised so far. One is the handhelds with an audio TNC and a smartphone and tablet. I sent out a report on my studies on that a little bit ago. There are a set of commercial alternatives of which John is looking at the HG. It apparently is in New Jersey and it should be getting to him shortly. So we look forward to that data.
What are the alternatives that we're looking at?
Anytone, there are two different Anytones plus the Lanconen. I don't know how to pronounce it, but whatever.
John, before you went ahead and bought stuff, you could have talked with me about it because I've got a lot of experience with those radios, but
And do they work?
not really.
What does that mean?
It means that, well, first of all, so that's why it was like, if you guys want, we should kind of talk before people spend money, because especially for something that expensive. So the first round of Anytones were transmit.
Well, I didn't get the Anytone. I got the Chinese one. The last one next to my name.
The last one next to your name.
The HG UV98.
Oh, okay. All right. I see. I'm trying to understand the layout of this table a little bit. Yeah, so I mean, just as far as Anytone goes, I've got tons of experience with those. So the first round of the 868, 878, and then the 578, which is a mobile, Anytone claimed APRS support for them. They support DPRS, so basically digital APRS over DMR, but they claimed analog APRS support as well. They were analog for transmit only. There's no TNC in them, so hardware, there was no decode whatsoever, no discriminator, so not even the ability to use an external TNC with them. Now they released the plus, the UV2 plus, 878 UV2 plus. I didn't realize that they had already released the 578 plus, but they supposedly added a TNC in it, but it has very, very limited support. It does not support anywhere near as much of a feature rich or a rich feature set as like what we would find on Kenwood. So I don't know. I don't even know how extensive the messaging support is, but at least they got closer in that for analog APRS, they are able to handle both transmit and receive with decode. So they're getting closer, but Anytone's definition of APRS support is definitely to be questioned.
Yeah, and I've just put this up as a list of various things. You notice they're volunteers for only parts of this.
What about the like the tracker, like the tracker 3 and 4?
I don't have those. We can add them to the list. It's the goal.
I might be willing to pick up a 4 if I can get my hands on them from Argent Data
As we'll
Systems.
see, my focus had been on, could we use it effectively at the AT Golden packet? I'm not sure that trackers work for that particular mode, but I could be wrong.
I'm going to send it in the chat just so you guys can see which one I'm talking about. Go ahead. Sorry. Continue.
So there's some newer smart TNCs out there. The MobileLink TNC3 is the obvious one to look at. There are a lot of SDR radios that can support APRS, and they require a different way of interacting than does a more traditional analog radio. And I see I have a typo. That should be the IC705. I'll go fix that. And then,
What are
of
you
course, then there's
holding up there, Lynn?
I didn't want to interrupt. I was trying to show Jeff Tracker 4 does exist. It's right here.
Oh, very nice. Okay, cool.
I've done no testing whatsoever on its low signal ability, but it does parallel all the other TNCs I've played with from a hardware TNC perspective.
Okay, excellent. Yeah, I just know that, I mean, obviously components shortages are affecting everyone, including including Argent. So I'm gonna reach out to them and see if they have any available. Go
Okay,
ahead, sorry, Don.
sorry for that interrupt.
That's not an interrupt. That's what this is supposed to be. It's a discussion. Okay, and then of course there is the software packages talking through the audio chain to the transceivers. And as we'll see, the 6-pin mini DIN right now has some importance here. So one of the things Jeff asked me to do is to try and come up with requirements. In my career, one of the things we'd moved to was narratives, because that immediately maps to a test suite or a test effort. So I've started with narratives, and the primary one is you're on AT Golden Packet. You drive up, you want to get the beaconing running, you want to get the digipeating running, you get EPRS messaging up so you can interact and coordinate. And at some point you switch from 1200 baud to 9600 baud. That's pretty much what I remember doing when I drive up to the site. There are other narratives.
Can I interject one thing on the ATGP one?
Sure.
It is really important to be able to see the packets that are going through your station, so you know who you've heard. And if they're updating their statuses, you'll be able to see that they're copying you as well.
And
So-
that takes me to the requirements.
Okay.
And the monitoring received packets was caught there. So the first question is, are these in fact the requirements? This is what came up in the conversations of varying sort. Well, I'm sure it's not complete, but this is what I was able to glean from various email chains. You basically have to beacon, you have to digipeat with modern routing. You got to monitor the received packets. We need to support messaging, and we need to support 9600 baud. That was brought into the picture by Bob Graninga.
And the beaconing, I would add, you need to be able to customize your beacon text so you can reflect your status of what you're receiving up and down the chain.
I will go update it with that, Lynn.
Because some of the solutions, that's not an easy thing to do.
Right. Okay. Got it. I will update that.
Don, do I have the most recent version of this deck, or are you using a newer one?
I'm using one newer than the one you have.
Oh, okay, I was gonna say, because if you wanted to, I mean, I could show them from here and I could live edit them, since I know you're using a tablet, so, but go ahead.
Yeah. Yeah. And then it has to be simple install, configure, and maintain. Simplicity is important here. We don't want this to be a technological tour de force to keep it running. And the goal is to have a functional equivalent of the Kenwood D710. I explicitly did not put an A or a G after it, just left it as a D710. And this brings us to the question, are these the appropriate requirements? Beaconing with editable text was brought to the picture by Lynn, so I'll go add that. Any other changes to these requirements that we need?
So, I mean, just looking at what the configuration requirements are, and I don't know if these are requirements because of the fact that it's a Kenwood thing or an APRS thing, because I don't know what some of these do, but give me just 1 second here. Let me pull these up here. Radio configs. So like UI flood.
That's part of the digipeat with modern routing.
I'm sorry?
That's part of the digipeat with modern routing. So if you
Okay,
call
and
them
then
off, I'll
like
tell you where I think they
alias-
fit.
Alias hop and UI trace substitution
part-
ID.
Same thing in modern routing.
Okay,
Yeah, that's, I explicitly put the modern routing in here because we need all of those features so that we can effectively move up and down the chain.
okay, so I mean, if it supported these options, but maybe not necessarily every mobile modern routing option, then that would be sufficient, right?
If you support modern routing, you can configure what the word is. Instead of wide, we use hop.
Mhm.
And you'd be able to configure whether it does what Kenwood and other TNCs call UI flood, which is whether or not you insert or replace the digipeater's call sign. And for the golden packet, we need to replace all the previous path with our Digipeater call sign. Otherwise, the packet gets way, way too long if everyone inserts their own. So
Interesting.
that's all bundled in modern routing.
Okay.
So we
Cool.
need you, so I think we should bring, I should bring UI flood there in specifically, so we check for that.
Yes, because we absolutely can't handle call sign insertion. We need call sign replacement by the Digipeater.
All right, I'll update that to include as a sub bullet that it must support UI flood. Because that is something unique we need to check to make sure it does the pieces right.
Yeah.
Yeah, that's why
Anything else?
I made sure that when I wrote the summary of what today was going to be, that I wrote APRS as it pertains to the golden packet.
Yeah. If you look at the narratives, I think if we do golden packet, it'll probably fit most of the other narratives, but this is golden packet. We got to make sure it does this or it doesn't really fit the game. Any other changes or tweaking to the requirements? Oh, come on. Okay, then I'll move on.
Sounds good.
Go ahead.
I just mumbled, sounds good, looks good.
Yep.
All right. So there was this set of email chains, and I've tried to extract all the email chains, condense them down so that we've got it documented. Yeah, we basically decided we thought we wanted to explore possible replacements. There's a conversation that focused in on software TNCs as opposed to hardware TNCs moving forward. And we talked about the Raspberry Pi as the target. Other things got brought up. People suggested an Arduino, but nobody picked it up to carry it further. There was some minor talk of some hardware TNCs, but when one poked at those hardware TNCs, increasingly they were software TNCs, just one you couldn't get into. So we ended up, after that conversation, saying, yeah, this might be fun to do. It looks like we should use a Raspberry Pi. And when you do that, you probably end up with Direwolf. That's the most plausible. And so that's where most of the work has been going on. There was another discussion which was not as well fleshed out, and we really need to surface and talk through, and that's the radio interface. If we're going to do 9600 baud, we need to get access to the discriminator and directly to the modulator. And effectively, under the old way of doing transceivers, that means we need to have the 6-pin mini DIN or its equivalent. When I say the equivalent, that's the 9-pin on the DR135Ts, but they just repackaged the 6-pin mini DIN. We can't go directly through the audio chain. So our decision for 9600 baud constrains interfaces we can use. We can't just use the microphone interface. And we need to all understand that up front and recognize what that means. We also get an advantage that early testing shows if you do use the 6-pin mini DIN, then some current concerns that were raised earlier about everybody having to adjust their audios seems to be reduced. The testing so far says we can use a single audio setting for 1200 baud at least, and it works across most of the radios we've tested with 6-pin mini DIN. So for those two reasons, we've ended up looking at the 6-pin mini DIN, but we need to do that explicitly and with intent. We can't fall back into it. So comments about the 6-pin mini DIN.
So,
Uh,
oh, go ahead. Go ahead.
Could you talk a little bit about what you told me about the ICOM's USB interface on the 705? I mean, in theory, at least the modern interface is going to move to a USB with the sound card in the radio. But you told me that was bandwidth limited on the ICOM radios.
So the correct statement here is when I did reading on it and looking up on specs, it appears that the bandwidth of the USB port on the 705 is approximately 3 kilohertz, does not give us access to the 8 kilohertz that we really need for 9600 baud. That's what my reading has been. I have not tested that, and it's been inferred from some of that reading. I can't test, the reading was not explicit, or the material was not explicit.
Well, certainly that's something we can test. The other ICOM radio, don't you have one, Jeff? The expensive ICOM VHF, UHF
Yeah,
base
I
transceiver?
have a 9700 that I just got,
You know if the and that has a USB interface, correct, Jeff?
of course, yeah.
And I wonder if the USB interface on that 9700 is similarly limited.
Don, where did you, well, let me ask you that, Don, where did you read about the specs on the 705? Was it just in their documentation or elsewhere?
No, it was elsewhere. It was a discussion on building digital interfaces to the 705.
Well, the
need
reason
to
why I
go-
ask is, I mean, I was just, if it was in the documentation, I would say, all right, fine, I'll go look at ICOM stocks just to see if they have the specifications listed there.
Yeah, we need to go confirm that.
Okay,
Um,
so we need,
I
what
don't-
we're saying is that the audio interface needs to be 8 kilohertz. The USB audio interface needs to provide 8 kilohertz in and out.
Yeah, in and out for 9600 baud. That 8 kilohertz, there are test data that shows we need 8 kilohertz. That, and it is also theory, which is published by Steve in the Direwolf manual, that also shows we need 8 kilohertz. So I think there's both theory and practice. It says it's 8 kilohertz.
Okay,
Simple Nyquist criteria says, yeah, it's probably around 8 kilohertz. I would have thought it was a little higher, but the test showed that if you rolled off at 8 kilohertz, you were still fine.
okay, I know where I can go find out.
Yeah, even if you don't dig it up out of the real specs, I put in the chat the proposal as to how you can just test this. If someone has one of those radios and a Kenwood, just hook up Direwolf to your USB audio, set it to 9600 and see if it can interoperate with the Kenwood at 9600.
Okay,
It will or it won't, regardless of what the bandwidth is.
so as far as, and I mean, just sheer ignorance here, but when tweaking audio levels, I mean, how, I guess, I mean, obviously you don't want to redline it, right? But I mean, how hard do you drive the audio, the gain levels on the audio when you're setting up Direwolf? I mean, I haven't really spent a whole lot of time focusing on that.
Well, so it turns out Transmit seems to do just fine with an ALSA mixer level of about 29.
29?
Yeah, it's about 29 is what I use as a default. On the input, the audio level by default is up at around 50. And Direwolf will decode it just fine, but gives you a audio level too high error message. I set it down to, I believe, around 13. That's my standard. And at 13, it comes in at about, I don't know what the Direwolf number means, but it says 59 and it doesn't complain about it. And it decodes everything. It looks like that's about 3/4 of the audio space. I don't have a really good number on that.
But Direwolf will give some sort of an indication as to whether or not the signal is too hot if on the console then?
On the receiving, yes,
Okay,
not on transmit.
okay,
And what I did was just tweak the volume until it stopped complaining. And it was about the number in whatever those values are that Direwolf reports that they more or less said they like to see. So, and once I got it there, then I just kept plugging into different radios on the 6-pin mini DIN and everything worked. And had the same receive audio numbers on the Direwolf log. So, you know, we need more data, but I've done it 2, 3, I think we've done it 4 times and have the same result. So 6-pin mini DIN levels seem modestly stable for 1200 baud. You do have to increase dramatically the transmit for 9600 baud needs to be driven up to about 60 in the ALSA mixer screen. I don't have that one as well timed, but if you use the default on 9600 baud, I can tell you that you will produce no discernible audio signals. So you got to go increase it by around a factor of 2.
John, WB2OC, any, any comments from you on this? The points about audio? Maybe on mute here, let me see.
For the deviation, you want it to be wide enough to use most of the available, I don't know, audio range, but you don't want it so large that it'll be distorted. So, I mean, you could really do it by ear. You could just crank it up until it doesn't get louder anymore and then crank it down a little bit. That's probably good enough.
Okay,
And that's approximately what I did to get my approximate numbers. We need to do more work on getting those numbers more precise.
okay.
So
Excuse me, I just put a minor note into the chat on decision 3. Is WB2 OSC Steve or John?
John,
John, sorry,
Okay.
Yeah.
Slide has a little glitch there.
I will fix that. Thank you.
If I could just comment on that, the thought I had going forward is I would imagine in the future, we're going to see a lot more USB interfaces, and maybe even the mini DIN will get depreciated. And if the trend going forward is that the USBs are going to be bandwidth limited and they're going to depreciate the 6 pins, that's not a good trend. That's something we need to be concerned with.
Yeah, that would be a death knell for 9600 AX25.
And I think that's something we need to understand and quantify better and then respond to. My immediate thoughts is we actually need to give feedback to the vendors so that they understand what the challenges are and support it better. But for that, we're going to need test data, and we're going to need to show that there are people who want it. And that's what I think one of the things this group can do. All right. So that takes us to the sound card. I'm going to skip that. Here we go. So this is a list of sound cards that people have bought at least one of in this group and done some early testing on. Signal Links, All-Star, typically the Dyna, FE-Pi. There's also an auto injector that is the alternative for the DigiPi work, and then USB fobs. I think those are the sound systems that we've got. Someone has pulled in. Have I missed any that we're working on?
Yeah, the
Not
one I
really.
had posted.
sorry, go ahead, John.
You remember the one I had posted? It's in the nice little aluminum case, and a USB comes in, C comes on one side, the
Mhm.
other comes out with your mini DIN connector.
Yeah, I'm just looking it up right now.
Yeah, I'm trying to remember the name.
Yeah, this list was based on somebody in the group had bought one.
DigiRig,
DigiLink.
DigiRig, RIG.
No,
The one I
it's the
posted was
DigiLink.
DigiLink.
DigiLink
Okay,
is the
yeah,
sound
so,
card.
let's see here. So there's also, hang on a second here. Let me send this in the chat. So there's also this DigiRig,
Yeah,
and then as you said, the DigiLink Nano. I
no,
think both of those appear to be worth testing.
so I only put a line here if somebody had bought one. So if somebody goes and buy one, then the line will appear.
Okay,
Okay, that's how I
Um,
built this up. If nobody's willing to purchase one, then yeah, then it becomes purely esoteric. Once someone buys one and starts testing, We absolutely need to track it.
Can I expense this? It's not that kind of event. I got you. Never mind.
One clarification on the Signal Link USB.
Yeah.
It lists the push to talk as Vox. It's
Yeah.
actually, the Signal Link does the PTT. It's not Vox in the radio.
Oh, no, it's
Right.
Vox in it's Vox in the Signal Link.
Right.
Right. So.
And there are a number of those. I can update that if you like, but there are a number of these. The DigiLink, for example, has Vox in the sound card as well.
Right, whereas the USB fob would be Vox in the radio.
All right, I will update that to get those two clarifications.
Yeah, 'cause,
USB,
Vox-
which USB fob are we referring to?
just generic audio USB fobs.
Oh,
It's
okay.
a cheap radio mic interface,
Yeah,
and that would require the radio to do the Vox.
Yep,
And that's what really doesn't work well,
okay.
no,
most experience.
And
That's just a little USB fob that has the two 3.5 millimeter plugs on it,
Yep.
right? Okay,
yeah,
you
but
have one, I have a different one. I'm sure everybody has one kicking, pretty much everyone has one kicking around.
But if it has a C media chip in it, like a CM108 or CM119, it's possible to drive one of the GPIO pins for push to talk. That's what the Dyna does.
Yep, and that's you notice I said home integrated, and I said integrated, not built, because I was trying to be very general.
sorry,
There is an
what was the comment
all-star-
again? So if you have what is it, a C108 or a CM119 or CM108, what was it possible to drive? What?
Yeah, the 108 or the 119, and there's a couple others in the family, but those seem to be the two most popular.
And what's the advantage of them again? That was
Well,
Oh, you can use GPIO 3 on the sound chip to provide push to talk.
okay,
so that makes it very tidy, and that the single USB connection can do the push to talk as well as the audio.
okay,
And in the software, that's frequently identified as CM108 GPIO or some version of that.
got it.
Okay.
Thank you.
This is GPIO on the sound chip as opposed to GPIO on the computer processor. So you'll see in the PTT the difference there between where the GPIO is coming from. So I'll skip that. So I built one of these. This is the FE-Pi system. I'm not going to go further with this because fundamentally, it's like hen teeth to get an FE-Pi. There are also some construction challenges with this, but if you go through the DigiPi group on groups.io, I think that's where it is. It could be Google Groups, I forget. They actually show alternate ways to assemble this, which are much more solid. But if we can't get FE-Pis, then I'm not going to invest more time in this. I did build one, but I'm not going to really spend any effort on it.
No, I wouldn't burn any cycles on it. I mean, we know through Craig that it works with 1200. 9600 is to be determined, but I don't know. I mean, I think we've got more robust options in some of these more, like DigiRig or DigiLink Nanos and some of the other options that we're looking at. They seem a little bit more robust than the GPIO.
Yeah, then then the FE-Pis. Okay. And then
Yeah,
I
so
produced,
as far as the FE-Pi that was concerned, so did he, Bud, did he end up pushing back and say he wasn't selling them?
yes, he said he would not sell them to me except for test. He'd give me one test unit, and that was all he was going to sell for this. He wanted to have it tested. And that's what I promised to do, but he said, yeah, that's the end of these for DigiPi. He
Interesting.
was quite
Okay.
explicit.
Okay.
So I think this is an end of life here. I built one. I know what it looks like. I've got the parts for alternative designs, but I'm going to move on. This is where I've been spending my time. And let's bring back here. And I will turn the camera around. So the unit that I spend most of my time with is this beast here. It's a Raspberry Pi 3. I plug a USB dongle there. Plug in the Dyna.
Slow down your movements a little bit. They're very
Yeah. they're
bouncing
very
around a
janky.
lot.
So I plug in the dongle for the Wi-Fi. That I plug in a Dyna, and I'm going to make a plug in the GPS. And if it'll come back. And if I put in power, that'll come up. I'm not going to demo that one because everybody seemed to be focused on the zero. You can see the zero set here. To make the zero, I added to it a Marketplace USB hub, and then I had a friend of mine build me a little case. And I'm not going to show you building it up, but hold on.
While we're waiting, this is another alternative to not needing a USB hub.
Yeah.
Mhm.
It's a USB
Squid.
on the go with 3 USB ports and a charger port. So you can still power in through it if you want to.
Yep.
So
There are any number of ways of doing it. I found a little hub that was like 12 bucks that fits on the bottom of it, and people like the size. Actually, it's the beginning of an exercise, which is going to go explore some more ideas here. But it should be up.
oh, I see. So your hub is actually mounted on top of the case of the Pi Zero.
Right. Actually,
Got it.
underneath.
I see it
That's
now.
neat.
And then it's a little case, and then everything plugs into it. And it takes about 1.5 minutes to fully boot because the Pi Zero is a little bit slow.
So that's a 0, not a 02W.
Yes, that's a 0 because I didn't have a 02W available when I was doing this. I have one on order.
That's good. Okay. Good to know it works on the older one.
So I connect.
If you can join that to the meeting, Don, you can share the screen on that.
That's actually hard. Excuse me. Didn't start up cleanly, no problem. Okay. And once everything starts cleanly, I bring up APRS IS32.
We just see your hand on the touchpad right now.
Yeah, sorry. So
There
I've
we
got, this connects to it. It's going to take another about 15 seconds for everything to come up. Yeah, there we go.
You're using a KISS over TCP to get to Direwolf on the Pi Zero.
Yep.
Okay. Looking for what interfaces I need to add to my Android test host client to make it
All right. And
usable for this
obviously it's
situation.
booting up because it's not booting. No, that's not, Direwolf's not starting. Let me try it again. You know, the sound card wasn't fully plugged in. And then I'd usually take the Raspberry Pi 3 version. I leave that in my car and I just watch it and track it, and make sure it's stable wandering around.
Are we supposed to be seeing something?
We are, but something's not quite working right. Oh, because I didn't spell direwolf right. There we go. All
Well, I
right.
mean, we were just seeing black, so
Yeah.
nothing.
So now you're seeing direwolf. This is connected. I'm gonna go make a beacon. Now, let me do one thing first. Start up the interface on my iPhone.
Yeah, there's almost no point in sharing this with the camera this way.
And, well, that's the only way I can. And if I now beacon, you'll see that everything starts measuring, starts receiving packets and things appear on computers and it's all working. So it just plugs together. And if you use the image that I've posted, I have in the deck, just put that in, change your call sign in the direwolf and connect to your Wi-Fi, and it should work out of the box. So I'm going to go back to the deck. Oh, hold on. So questions on this beast?
What radio are you using there?
I'm using an FT817.
Okay, so you do the 0W is connected to the 817.
Yep.
Got it.
And then the 817 lives in my car and we go from there. So those are the two systems. Takes a minute and a half to start up. And I've left it in the car, turning the power on and off without trying to be very kind to it. And it has not had any problems. So it's a solution. Stop that. It's a solution. I've got instructions. You can go build one. It's about 120 bucks worth of parts. Order the Dyna, and then you have to, on the Dyna, cut JP3. Otherwise, you'll get a carrier on sense, the squelch signal, and you'll see odd behavior that you don't like. And of course, you got to put a Raspberry Pi into the case, but that's all the assembly is required. Questions on this prototype?
So you could, with that prototype, test 9600 baud on your 817.
Indeed, that's what this next slide is all about. It tests 9600 baud. A little bit of an annoyance because it's a physical change to the wiring to run 9600 baud. You've got to run the audio instead of the 1200 pin. You've got to run it to the 9600 pin. But if you get this little device or little adapter from MobileLink, plug that into the Dyna and your cable into the other end. And that does all the physical changes you need. And then you just have to change direwolf to go to modem 9600 baud. And you got to go set your radio to 9600 baud. So no physical changes required inside any of this as long as you have this little adapter. And I've tested this at 9600 baud. Raspberry Pi 3 will do it just fine. It's about 50% of the CPU.
You don't even need to
Raspberry-
cut jump. You don't even need to cut jumper 3 with the MobileLink.
Well, you always must cut jumper 3. The reason you got to cut jumper 3. Do you want me to go into the details or merely tell you to do it, Jeff?
Just the really short version.
Short version is that there's an assumption that was made in All-Star about how the COS signal would be handled, and both Windows and the Raspberry Pi operating system by default don't work that way. And what happens is you'll keep getting a signal on the COS and it will reduce the volume, and it'll keep reducing the volume until you're muted, and then you'll stay muted.
Okay, got it.
They intended to get the signal, cut off transmission, and when the signal went away, restore it. but that's not what the audio drivers in the operating system do. So go cut COS, bring this cable, and you can switch in a matter of a few minutes, or about a minute, between 1200 and 9600 baud. And that should work with any of our sound systems that are using the 6-pin mini DIN cable at the sound card.
Just a curious question. I'm not intimately familiar with Direwolf, but is it possible to tell Direwolf to use one decoder at 1200 baud and another decoder at 9600 baud from the same audio source?
Yeah.
So that when we
Oh.
want to change over, we
Oh.
don't have any modifications to Direwolf itself.
I have not found that. If you look carefully in the direwolf.config, it's got a line that says modem 1200. And if you wanted another speed, you have to comment that out and put the modem's the other speed.
I mean, I guess you could run 2 instances of it with different config files.
And
My
different ports.
understanding is if you specify a modem of 9600 to Direwolf in the config file, and it receives the 1200 baud signal, it will decode it.
No, wrong. Okay.
Okay, I
Direwolf,
stand corrected.
Direwolf has only a single modem type for each audio channel. But what you could do is run multiple channels with different modem types and feed the same audio into both of them. I guess the brute force way would be to have 2 different audio cards or sound cards with inputs connected together, but you can also do it through some magic and ALSA, ALSA, however it's pronounced, where you can take a physical input and then in software split it so it looks like 2 virtual audio devices. People have done it, but I don't have the notes on how to do
Or
it.
is that like using the virtual syncs to redirect?
Exactly. There's one physical audio input, but then also routes it to 2 logical devices.
Yeah.
So you could set it up so that a single instance of Direwolf has, let's say 1200 on one and 9600 on other. It thinks it's listening to different audio interfaces, but they're really coming from the same place. And then it will be reported to the application in the channel number in the KISS interface.
And does that also handle transmit out the 2 different channels?
Yeah, you could then do the same thing. You could then transmit on either channel and then just mix the 2 virtual devices into a single physical device out.
That's neat.
And with an approach like that, we don't have to do anything to the Pi to change from 1200 to 9600. You just put that little adapter cable in your 6-pin mini DIN, and that's actually selecting which audio path is going to get a good signal.
I like that.
I always use the 9600 pin, even for 1200 baud.
That was going to be my next question. Can we just use the 9600 pin for both baud rates?
That's what I do.
I think
And-
that might get into some audio level issues because it's not taking the same audio path. But once we set what those are, it should be constant.
Yeah, I think it would be one constant because it's the audio coming out of the discriminator, or excuse me, discriminator or audio going into the modulator. And it doesn't, and neither of those know whether it's 1200 or 9600. They just know the signal level.
So
Yeah.
that would be one that you can easily test with your setup, Don, is
Yep.
just put your 9600 baud mini DIN in and see if everything works good on 1200.
And I can do that. I will go run that test.
Very cool.
Okay, and then then if we do that, then the only thing that has to be changed to switch back and forth between 1200 and 9600, well, unless we can get really fancy with the direwolf, you're gonna have to change the direwolf speed, and you're gonna have to change the, your radio is gonna have to change. You gotta set up at 9600 baud.
Depends on the radio. Some radios don't care.
I would
yeah,
just
it's
say,
true.
always leave the radio at 9600 because the extra bandwidth does not hurt.
Yep,
If you're using a lower bandwidth
Yep.
signal.
Yep.
And as far as direwolf is considered, a single instance could then receive on different channels, 2 different speeds. And when it goes to the application, there's this 4-byte field in the KISS frame that has the channel number. So the application could use that to distinguish if it felt the need to.
Yeah, we just have to get the author of that APRS IS32 application you were showing to support transmitting on anything except port 0.
That guy's turnaround time is horrible, though.
Yeah, it is.
Sorry.
That's been on my, quite literally, Jeff, that's been on my to-do list for about 5 years now.
Oh, okay. I'm teasing you, by the way.
I know, but the APRS IS32 receives on all the ports and displays it, parses it, everything's fine. But transmitting on multi-port KISS only goes out channel 0.
Huh. So
Yeah.
but you have the, I mean, it obviously coding required, but you could redirect output to multiple destinations then.
It's not really that easy.
Okay.
Unfortunately, it's due to my naive understanding of what TNCs were when I originally coded the stupid architecture. I did not realize there were multi-port single connection devices.
right.
So is it one of those situations where you have a significant amount of, not
It's-
necessarily starting
it's-
over, but going back and,
Re-architecting, literally. It's
Okay.
likely to be supported in my Android client before it is supported in my Windows client.
got it.
Well, and we have an additional problem that, at least right now, the only known access to that circuitry is through the 6-pin mini DIN on a radio, or equivalent DR135, for example. But in any event, even at this level, it's not too hard. It's a matter of about a minute or so for me to change over between 1200 and 9600 baud, even with these 3 steps.
This is
The
pretty
Anyway.
cool.
problem I see with it is in the field, it's error prone.
Yeah, so the obvious thing is to always then just use the 9600 baud functionality and drive it at either 12 or 96.
Right.
And that's trivial to do, and I can go
Sure.
test it.
So as far as, I mean, what you're running on the Pi in this case, then, I mean, is it really just nothing more than just a Pi with Direwolf, or is there more to it than that?
It's just a Pi with Direwolf and GPSD.
Okay,
You know, again, back to the rubric, we were replacing or finding an alternative to the Kenwood D700. And if I go back to the requirements, all those can be met with Direwolf. And then I need a graphic front end, and I can, as I've shown, I can either use APRS IS32 on a laptop, or I can use APRS.FI on a phone, and both of them work. And so you send your messages from the graphic interface, you monitor the signals coming in from the graphic interface, you have a moving map on the graphic interface. And that's what you use when you have to sit there and want to work with it. But even if the graphic interface isn't running, beaconing's running, digipeating's running, all in the background.
I really like the solution that has Direwolf doing the digipeating, because that is a self-contained little unit.
yep,
And
Yep.
it decreases the moving parts that have to work for the station to be fulfilling its ATGP role, which is a digipeater fundamentally.
Yep. And and it turns out the whole setup literally maps perfectly to the design that I use with my D710A when I'm on the AT Golden Packet. The only difference is I got a Pi with the radio in front of it as opposed to D710, but literally the layout looks exactly the same otherwise. So anyway, so it'll do 9600 baud. Some things to remember. Raspberry Pi 3 will do 9600 baud fine. It takes about 50% of the CPU. Raspberry Pi Zero W, the first one, yeah, it's not strong enough. It can't handle it. It can't handle it. But the Raspberry Pi Zero 2W should work just fine. W, if you just use the Pi Zero, you're going to get a complaint from Direwolf that it can't get enough CPU capacity, and it'll give you an error message.
Okay, I have a couple solutions to that. I rewrote the 9600 demodulator to be more efficient, and that knocks the requirements down some. And then you can just run a single slicer rather than all 9, and it does not decrease the receive quality very much. I saw something like 4% using genuine signals.
Yeah, given that the Pi Zero 2 is coming, my image of what I see happening is if I have a mobile rig, I'm going to have a 3 on it because it's actually a little simpler to configure. If I want a really compact system that can do 9600 baud, my FT817 perhaps, I'll use a 2. If I'm on a handheld transceiver, it can't do 9600 baud. And I'm also probably going to want to run it from a battery, so there's no reason not to use the straight Pi Zero there. And since the image works across essentially any Pi we've tested Pi Zero, Pi 3, and Pi 4, and I'm fairly confident it'll work on the Pi Zero 2. I don't think there's any reason to tweak the Direwolf. We just upgrade the Pi Zero to a 2 if we have a system that justifies 9600 baud.
Yeah, my concern with trying to leverage the Pi Zero with the tweaks for the 9600 baud, John, is that 4% of the packets that you saw no longer decode to make it fit on a Pi Zero are probably 100% of the ATGP packets at some of the sites, because we're talking very low signal, no collisions. We have our own frequency, but very, very low signal strength. So by removing the decoders and stripping it down, I'd be real concerned that it loses its low signal capability that we're going to need.
It's a command line option, so you can
Okay.
change it,
And
for your particular situation.
right, the 2 is so cheap. It's like, why not just get a 2? They should be available by the time we need them for deployment, I hope.
Yeah. Well, I'm finding that they're it's about a 2-week lead time if I want to get them cheap. And I can get them immediately if I'm willing to pay more money.
To get what is this now?
A Pi Zero 2.
Ah,
I've got 2 weeks lead time if I want to if I'm willing to spend more money, I can get them in 2 days.
yeah, I mean, I ordered mine. Mine came a lot sooner than I was expecting it to.
So I don't think it's worth doing that. I think we're going to have a small niche that's going to want as low power as we can get. And then we just put a Pi Zero in that. Everywhere else, we either use a Pi Zero 2 or a Raspberry Pi 3, mostly depending upon taste. But be that as it may.
And if I finish my Android client to work on the Pi 4, you could actually deploy a Pi 4 with the user interface, the Direwolf, and everything else on that single unit if you put a display and keyboard on your Pi 4.
Yep.
How you can run Android apps on the Pi?
No, but my Android APRS client is developed in a platform that lets me run on Windows, Android, Linux, and supposedly iOS.
What platform is that?
It's called Moai, and I code in Lua.
Moai, how do you spell
Moai.
that?
Moai, just like the heads over on Easter Island.
Got it.
It's actually a gaming platform development suite
I see that.
that you do all the coding in Lua.
Interesting.
And I do have it running on the Pi 3 and the Pi Zero 2W. I'm real anxious to actually see if it works on the DigiPi image side by side with Direwolf on the Pi 3. And if it does, then we've got a user interface if you just give it a keyboard and a mouse, a keyboard and a monitor.
I like it.
Well, if you have a touch screen, you could have a virtual keyboard.
Yes, actually.
Yeah, so the guy, I mean, so DigiPi, he has, what does he call it? It's called No VNC. But it basically, it is a browser-based VNC client. So he runs the Pi 0 or 3 or 4, whatever device you happen to be running it on with the VNC server. And then when you go into the DigiPi interface, he's running WSJTX and FLDigi on it. So when you go to either of those apps, you launch it, pops up another browser tab and makes a connection with this No VNC. And I mean, you have a keyboard and mouse hooked up Bluetooth and do your thing. So no HDMI needed, no
Yep,
cables.
Once we get the radio and the TNC and everything else stabilized, then we'll tackle the options. And when we get to the user interface, as long as the connectivity is there, which one any individual chooses is kind of up to their own preference.
Right, yep,
And what
that's,
they want to pack in with them.
yep.
and that's where we need to be. The key, that's why I drew that block diagram up front, is because I realized that there was another level of decomposition of function that we needed to capture in our thought process. Be careful, because you may need multiple GPS signals along the way. That's the only thing that becomes a challenge. In any event,
Well,
96
for ATGP, we do not need a GPS at all.
true. No, the reason I used a GPS actually was because I wanted to simplify the configuration. And so rather than make you have to input the coordinates, you just turn it on and the GPS puck fills that in. And therefore I reduced one level of configuration and one level of mistake. And now all of a sudden the same thing works fine as a tracker. So good GPS pucks are about $16 now. And by the way, they are so much better than the surf chips in the D700 or the D72.
Isn't it amazing?
Yeah, I just,
Yeah,
I know I'm increasingly do not want to integrate my GPS with the rest of the system so it can be upgraded as we move.
so a question, as far as, I mean, from APRS standpoint, time is accurate time a requirement, or?
No, APRS doesn't really care about time.
I didn't think so. Just wanted to make sure. Right, because then, I mean, that would be another reason to have the GPS would be because the Pi doesn't have a real-time clock in it. So people use the GPS to compensate for that. But if it's not a requirement, then it doesn't really matter.
Yeah, the only thing it's real handy for in the case of Golden Packet is time stamping your logs.
Ah, yeah,
And if one wants, as long as one's got a GPS chip, there's a standard NTP configuration that will allow that to provide the level of the Stratum 1 time service if one's so inclined, but that seemed like gilding the lily right now, given that. Well, I'll come to it in a second because we've got a challenge in front of us still. And so this sort of gives, I think it was Jeff asked me to look at, how can someone play? So this is a list of how you can play. You can play with a transceiver like John's doing, the HG coming in. You can take a PC and use any sound card and you begin to understand the sound card game. You can use a PC with a direwolf and you'll understand the direwolf behavior. The sound levels will not be matching the sound levels that we're using when we use Pi. You can use a PC with a Dollar card. That's even closer to the design we're going. Or you can play with Pi's and direwolf. It looks like pretty much everything is with direwolf as we move further up the chain. And this is your question earlier, Lynn. You want to play, get a PC, get a USB, the signal link, put direwolf on it, and you can begin to see how all of this is working. That's the second line. So where are we? We've got people working on the computer software TNC. We got the Baofeng smartphone thing pretty much done, and John's working on the HG. We have two different sound card systems, although I believe based on the conversation and the lack of availability of the FE Pi, we're going to depreciate that approach. We've got some working prototypes. What we don't have is objective data to make sure that these systems actually compare to the D700 or D710. We don't have field experience showing these things are resilient in the steep field. A little concerned about vibration with some of these things. We don't have field experience showing what happens when these things get insulted with power transients.
Mhm.
And we got a set of things on the 6-pin mini DIN that we need to know. And there's some long-term availability for all of this that we have to be careful of. And that leads me to John's continued argument. We need volunteers. The only way anything gets done is if someone volunteers. And so, what testing do we think we need? We don't have a test suite right now that says we're good. What's that test suite look like? I'm going to make a proposal.
Okay.
And I need feedback on the proposal because I'm not sure it's a good proposal. We have two types of testing we need. One is, can I actually use it in a application? And that means people need to build something and then deploy it and use it. I kind of like putting it in cars and driving them around, but your mileage may vary.
Yeah, so we're just talking about general usability testing at that
Yep.
point.
Yep. But we also need a quantitative statement. And the closest we've had to that is Bob Reninga's proposal, and I'm going to restate it slightly. We have a D710. We have in front of it a attenuator, and we have the person with a system to be tested somewhere in the far field, so we avoid all the near field problems. That's the tweak I did on Bob's proposal. And they make transmissions, broadcasts from their APR system. We receive them on the D710, and we increase the attenuation until the D710 can no longer decode it. And you back off a little bit till it just decodes, and you look at the S meter reading on the D710. And for that system, the D710 can decode it if it's at least this S level. It's what that kind of data brings us. Rather easy testing to set up. You can buy an attenuator for 100 and some odd bucks from MFJ, choose your source. Or you can go to QX and build one for, I just did the costing on that, it's less than $30. So attenuators can be done fairly cheaply. And it's a straightforward test to do. I'm looking for people to tell me whether that test actually tells us anything that's useful.
I think it does if we do the test again, where the system under test is another D710.
Mhm.
Yes, we got to do both.
Then
Yeah,
we have a comparable number with the
Yeah.
D710 that's receiving versus a D710 transmitting to it versus the new system transmitting to it.
Yep. Again, there's an assumption here that the direwolf can receive well. I have actually done some testing on that and can confirm that the direwolf software will receive and decode every packet that's seen by my D72, that I can state. So their decoding is comparable. And what we're concerned about is the transmission or the packet, the reception of the quality of the packet from various machines. So we know direwolf's good. The issue becomes then this
The hardware.
particular configuration of hardware,
right,
can it be received and where does it compare to a 710?
right.
And even that with your mobile solution of these new packages, if
Yep.
you have a D710 set up to receive in a fixed location with a fairly high antenna on its own frequency,
Yep,
and you have another D710 and these units under test,
Yep.
you go to the extreme of the decodability on the
Yep.
on the transmitter, and then you see if the D710 can go further or shorter than the new unit can transmit to that fixed point D710 receiver.
and that doesn't need an attenuator.
And that does not need an attenuator. But given that I'm in Florida, it does need more altitude on the antenna than I probably have because I lose my line of sight before I lose signal.
Yeah. Yeah, we got, where I am, I get a loss of signal because we've got a lot of hills. So I'm going to go order an attenuator. I was getting ready to do that, but didn't want to do that until this meeting had achieved some level of consensus. But I'm going to order an attenuator and start doing some testing in my location. And we can see what the early test results show. I think I can get Jeff Martin to help me with the testing, because you really need two people, one person at the transmitting system and one in the receiving system. Okay, what other testing should we do?
Well, this is my soapbox. The best testing that I know of, the opportunity for that is in the ATGP 2022, when we take our D710s that we still have,
Yep.
and we take these new units and we go
Yep.
to the mountaintop with them.
Yep.
Yep.
And we look and see what the new units can decode relative to what the D710 is decoding.
Yep.
And then working with your neighbors, you shut your D710 off or let it on, and you transmit a couple of packets from the new units and see if your neighbors can copy them on their
Yep.
D710s and or their new units.
Yep. And,
that'll give the ultimate proof of the replaceability.
Yep. Yep. But I suggest, and I believe John has been jumping up and down on this, before we go try and do this cold on the ATGP, John has suggested we do a springtime test to go debug the various systems and also get practice with D710 for that matter.
Yep.
And he suggested a set of APRS expeditions in the spring.
So I was thinking, as far as, I mean, we've got probably another 3 knowledge share sessions before that we can get through before we can start entertaining that sort of thing, maybe even 4. Lynn, I know you said December was out for you to present, so I'm thinking maybe you present in January as far as, these are all the different APRS settings and what they do and why we use what we do. And then come either next month or in February, we start putting together like a logistics plan and really hashing out what the field test is going to be.
Yeah, because if you look carefully, probably we want the field test in April as a target. That gives us May and some of June to fix anything we find. And that means that April, we start the logistics, in February, we start the logistics and we finalize them in March.
Yeah. I mean,
Now-
normally I would say that that sounds like it's really far away until I wrote that message last night and realized it's already been 5 months since we
Yep.
did Golden Packet.
Yep. So that leaves us with some questions. I guess everyone's here on the meeting has said they're interested in working on alternatives. Which alternatives are people interested in?
I'm very interested in testing the tracker. And, you know, potentially either the DigiRig or the DigiLink, I think probably the DigiLink Nano.
Right,
So those would be the two that I would be targeting.
okay,
I'll sign up for a Dyna interface talking to an Alinco DR135 from both a Pi 02W and a Pi 3B plus.
perfect, okay.
Yeah, actually, that's another factor that we really hadn't even brought up yet, which was, you know, what radios? I mean, I guess, I mean, we know we need something with a 6-pin DIN, right?
And I think I can add an ICOM 706 Mark II-G because I believe it has a 6-pin mini DIN on the back of it too.
Yeah, I believe you're right. And we've already tested on IC 7000, the FT817, the V71A, and I think it was an ICOM IC801, as I recall.
I have an ICOM IC 7100 here.
Now, 7100, I don't believe that has a 6-pin mini DIN. That's fed with a USB port, isn't it?
It has both.
It has both?
Yep.
Then you're good. Okay. All right. Well, we're beginning to get the collection. I think we actually need to understand how the systems work on multiple rigs. All right. Well, that's, I can try and capture that and send out an email with what I think I heard, unless you've already taken the notes, Jeff, in which case you can send out the notes.
Yep. I'll have to
Can
go
I ask-
through, I'll have to go through the audio of the recording again, just to get some of the finer points, but yeah.
Can I ask about testing configurations?
Sure.
Where I am here in Maine, when I have my D710 set up to beacon and DigiPeak, I
Yep.
get picked up on APRS-FI maybe once a day. Okay, and I'm
Yep.
picking up tons of packets on my 710 from other people. I have, the other thing I've been testing is an Android tablet with 2 ways, running APRS Droid on the internet connection. And that will, you know, report to APRS.FI. And I've also tested it with the cable going to the Biofang. And that will send RF packets to my 710 and receive from the 710. My issue is with APRS Droid, I can't do RF and internet simultaneously. It's one or the other.
Oh, dear.
So I have the issue of, you know, if I throw one in my car and go driving, I can't see the 710. I can see the one in the car, right? I can know it's receiving the 710, but I currently have no way of logging what the 710 is receiving. And so being in the boonies, I would like to get a test set scenario where one person can execute it and it doesn't require 2 people. And you can sign me up some other radios like the Raspberry Pi with my 705. And I also have a couple of radios with the 6-pin DIN like my 857, Yaesu 857.
Yep.
And I have another Kenwood with a 6-pin DIN on the back. But I need to be able to get to either software that logs or something so that I can effectively test.
Well, interesting. Go ahead.
No, go ahead, Don.
No, go ahead first, Lynn. I want to polish something. I have an idea, but let me polish it.
Okay, you're looking for just logging received packets, John?
Well, I mean, normally if I were in a more populous area, anything that was received by my 710 would get digipeated and picked up on APRS.FI. So it could be my logger, right?
Actually, that's not true, because if your D710 is digipeating it, if that packet was copied direct by any iGate, you'll never see your digipeated packet, and you'll have no evidence that your
Yeah.
D710 ever decoded it.
Ooh,
Yep.
No, but I would know that the radio that was transmitting was putting out a signal and being received. And APRS.FI would give me the log and show me who received it.
It would show you who received it, but it might not be your D710.
Now, I understand that. It would show me the path, it would have the
Okay.
packets and stuff. The
What-
situation I have is my 710 receive, say my unit under test in the car.
Okay,
You know, I can see I'm receiving the 710. If I were home, the 710 would show me to receive the car, but if I'm in the car, I'm not home, right?
okay, but the easiest way to do that, unless you're looking to see it real time, is just put your D710 at home, hook the serial port up to an APRS-IS32 instance on a
Yeah.
PC, and
Yeah.
let it packet logging for you, and it will log every single packet received by the D710.
Okay, and that's the little one that looks like a phono jack on the head unit where the GPS
Yes.
would plug in.
Yeah, the PG5, that little funky little 8-pin thing.
Yeah, it takes a Kenwood cable, or the who's the company that makes the programming software, RT Systems? One of their cables works as well, but it has to be plugged into the head unit, and that gives you an RS-232 that you can get into your PC, COM port onto APRS-IS32, and you're done.
Is somebody actually written that up? In other words, either that or Lynn, maybe I could talk to you someday and you could walk me through this.
Go
that-
to the APRS-IS32 wiki and look at the first use video and hooking up your first RF port.
Okay,
There's 2 videos there.
okay. This,
Yeah, I
part of
thought-
this, Jeff, gets back to, can we consolidate all this information in one place?
mhm.
Because it's all around the net and sometimes, you know, it's there, but if you don't know it's there.
Yep. Well, guys, we are over on time by a half hour.
But I think we got all the questions at least partially addressed. We have an approximate schedule and we have lots of testing started. So thank you very much for your time.
Absolutely, Don. Thank you so much for your efforts. We'll stay in touch with each other all on groups.io and Discord and
Yep.
all that good stuff.
And I'll send out a deck to the group with the tweaks that have been suggested as I've got them recorded. So
Please
you'll have.
do.
Yeah. All right.
And I'll share the recording of this, so.
And
Thank
are
you
we
for your
having a meeting in December?
Yes. Thanks, guys.
John,
Thank you.